So I'm cloning example, pet sitter service, Java Spring Boot. Copy. I will close this one. Close project. And get from version control. Pet sitter service, clone it. So, like in the previous example, I created project from scratch, but I copy-pasted her code. So I didn't edit a lot. I only changed this from Spring Boot 2 to Spring Boot 3. Whatever was required to make it compile. Also, she had somehow all examples from the textbook within the same project as sub-modules. And in this case, it was hard to navigate, so I separated just one module into separate project. I don't know why she did it. It wasn't easy to follow because it was one project with per chapter sub-modules, and I don't know. It was her decision. I cannot really say why. So I separated the latest version, like from late chapters, like close to end. And this project contains services already. So when I created the project from scratch, I selected web services, H2, and in-memory database. And I also selected validation because this is also using validation. It has validation constraints. So GPA, REST, validation, and H2. So I tried to keep the same structure, and I only made changes to make it compile because Spring Boot 2 versus Spring Boot 3. In base, she is defining enumeration types. So this program is using enumeration types as a flags. For example, pet type, cat, dog, bird, other. She is explicitly specifying that it's stored as integer, although we can just, and which integer, like 1, 2, 3. We can specify it without this information. It will still work like regular way, enumeration type. Also, for example, user type could be owners, pet sitter, or boss, or administrator. This is not complete program. It is unfinished project, but it is working web service. So we can run it and see how it responds to web requests. So let's continue. They grade each other, like how good was pet sitting and how good was pet owner to pet sitter. And this is the rating on this 4-point scale. And response status, accepted, rejected, proposed. It is response to request. I need pet sitting, and this is what somebody replies, and this was either rejected or accepted, whatever. So also enumeration type. Entities. In this case, we have indeed inheritance. She defined abstract entity, and other entities are inheriting from it. For example, pet is inheriting from abstract entity explicitly. See, pet is extends, it means inheritance, abstract entity. Abstract entity is marked with mapped superclass. Mapped superclass means inserted as columns. There are other ways to implement inheritance, and this is the most brute force and the most direct. Insert data from the superclass as columns. Inside of this superclass, we have ID. Technically, every entity should have an ID, so she moved this into superclass. And she also created fields for created at and modified at. So these tables will maintain the data. For created created it, it is updated automatically. This won't. According, I look it through code, this is not updated. So she doesn't have a code for it, for this one. So it will stay the same. There is also version information, and this will be updated automatically on every save. It is marked with version. It is not just to maintain number of editing, like count how many times it was editing. It's also used internally to check consistency if it is updated from two different programs. So it is this way it will reject if it happened in overlapping time. So it is also, in addition, besides like keeping record, it's also an extra consistency check. So let's go through other entities. Pet is inheriting the stuff. Pet is related to owner, and it is many to one. Many pets owned by one person. So it's an example of many to one, one to many. If we go back to owner, to user, we will see owner is user. We will see link to pets. See link to pets. Mapped by, this is variable on the opposite side. Cascade type persist and remove. Persist, it means it is safe with creating objects. And remove, when you remove person, it will remove pets owned by the person, which is logical, right? In this case, there is no point of having pet in the database if it's not linked to person who is owning it. So in this case, it's more clear what is cascade, more explicit. Cascade. Please notice that instead of list, it could be just set and as iteratable types. Also, we have reference to requests, one to many. One person can put several requests for pet city, and one to many, one person can respond more than one request. All right. That is user. Next, request. A request is linked to, please notice that this example is more clear on table names and column names, and just because it is specifying table names and column names explicitly, so when we do mapping, we specify foreign key, which column is a foreign key, because I think it's not because, it is just, okay? So to make it clear. Also, if we say JSON ignore, it won't appear in web service. So for example, in this starting date, stopping date, for some reason it's not appearing in, she decided not to put it in web service. There is also validation, and this is how it is stored, and it's also how it's validated. So validations are inside of entities for web service. And it's also applied when you click save to database. So we're looking for requests, and requests are mapped to pets, because requests can contain more than one pet for sitting, like sit for my two pets, whatever, cat and dog. And as you notice that this is many to many, and a relationship is looks more complicated than in previous example, because she decided to specify tables explicitly, table names explicitly. So it is many to many mapping implemented with request pet table. So it is specifically for many-to-many implementation. And we have specifications for foreign keys, right? So this is foreign key referring to field ID in those tables. So this is why it looks more complicated, because we have explicit specifications of column names and table names. And a response also contains reference to user who is responding, and a request. And request contains reference to the user who made the request. Also, validation for input, not empty, not longer than 500 characters. Right. And review, this is how they rate each other. This, I don't think this is actually clear why it is. It's definitely many to one, because for request, it could be several people review this request. Good, bad, just from outside point of view, including the person who is doing pet sitting, whatever. So this is probably why it is many to one. And please notice that this program is using enumeration type a lot, right? For example, review grade, it's also enumeration type. Enumeration type on Java side is not matching to enumeration type in SQL directly, so we need to provide information how to store it. In this case, it is stored as integer. In other cases, in this example, it is stored as string. So you have a choice to store enumeration type as integer. Enumeration type ordinal will convert it to integer, short integer type. And for example, pet type, in this case, it is stored as a string. Okay. So there are two ways of store it. Initialization of the database is done differently from previous example. In previous example, it is initialized, I didn't show. It is initialized from code inside of application class, In this case, it is done in separate class, marked with service, because system needs to create the object. It is forcing this object to be created, otherwise it will be ignored. And one of the methods is marked with post construct. If you mark method of service or a component with post construct, it will force this method to be executed when our object is created. And as we see, this is adding data to database. Right? Now we have repositories. In repositories, we have pet repository, request repository, response repository, and all of them are empty except user repository. In user repository, we have searches about users. Right? Similarly to what was explained in the previous example, with queries on top. Right? So let's run this project and see what kind of tables it creates and what kind of web service it provides. Okay. So unlike previous example, this will stay running, because previous one, you run it, it will quit. You cannot see tables in the previous one. Maybe it's better to modify it later, so adding service explicitly so it will stay running so we can browse tables. In this case, it is running, so we can go to H2 console. In resources, I specified logging, but there is no logging in this program. I will add it later, so I have it here. In memory database, H2, this tells that creates tables by, this is also a default option. Create tables from entities. This says console enabled true. I commented out parts of the data because if you provide it, it will be just in API subfolder. Remember our example for dice roller service. Data was in some subfolder, right? It was API subfolder. I specified this on top of REST controller. In this case, there is no controller. We have repositories. So in order to add paths to the data, if we want, we can do it inside of application properties. This is the way to go around of the fact that we don't have controller. So let's go to localhost 8080 and see. We see metadata that is listing resources provided by the program. Right? List of responses, list of paths, list of requests, list of users. Right? Okay. So let's go to list of users, for example, and paste it here. And it shows, here it is, array of user objects and resources linked to given user object. Right? User itself, himself or herself, themselves, requests made by the user, paths owned by the user, and responses made by the user. Okay. So this is how links, relationship link looks inside of this service. So if we go to localhost 8080 users 1, paths, it will be paths of the user 1. Right? So let's go there. No paths. Okay. Let's check the table and see. Okay, who has paths? Okay.
Mine has pets.
This program somehow automatically numbered this strange way. I didn't figure out why. Sometimes it starts numbering from 2. It's either internal bug or whatever. I noticed this yesterday, the same inconsistency. When we open H2 console, most likely it is started numbering not from 1 in my case. I don't know. It's probably bugging, is a library bug. We never encountered this in other programs because we specified counter explicitly which one to use. In this case, it's I don't know. Okay, so let's go to H2 console and see what we have. Localhost 8080 H2 console. What we figured out yesterday with the students in the class, it is still the same data, but now numbering sometimes doesn't start with 1, which is interesting.
Also, ordering is different for mine. Okay, that's why.
Yeah, maybe this is why. So we have a pet users, seater, owner, seater, and both. Let's open pets. No, numbering started with 1, but it is just different order. I don't know why.
Should it be in order from the initializer?
Let's think.
Because it's not.
Okay. Let's open the initializer and see what it's doing, okay? I wonder, maybe it is related to the fact that they're using set, and set is not ordered. So it has some kind of freedom to do it different way. I don't know. So let's open initializer and see maybe it is using sets as well. Yeah, it is set of users. This is why it's not ordered.
It's using hash sets.
Yeah.
Oh, okay.
So it's not fixed. So this is probably why it is in different order. So I need to correct myself because I was wrong. I said index not starting with 1. It's starting with 1. So it's not a bug. It is probably because she is using sets, and set is not ordered, so programs have freedom to do it different way. Maybe it's even random. So this is why sometimes it is 1, 1, 2, now it is 2, 2, 5. Okay. So what do we have? And she specified table's name explicitly, perhaps with p underscore to avoid conflict with other tables. Why? Maybe because in some SQL databases, user is reserved keyword, so we cannot use it as table name. So most likely, this is why she put p prefix in front of it. And okay, let's do it in front of everything. So in the set of the tables, we have, in the tables, we see entities, and we also see additional table, which is not entity. It is for many-to-many mapping. It is request pet. Requests are mapped to pets as many-to-many. Pet may belong to different requests, not belong, associated with different requests, like sit for my pet today and next week on Monday, right? So, and request may contain multiple pets also. So this is why it's many-to-many. So this is not entity. The rest of it is entities. So in pet, in entities, we will see created, add, modified, add, and version. And we also have pet type stored as a string. But pet type in database, it is, in our Java code, it is enumeration type. And remember that we specified store it as string, right, explicitly. In rating, there is also enumeration type, review its rating. And it is grade, but in this case, grade is stored as, why is big integer? I don't know. It is a choice of probably database driver, right? But as integer, kind of thing.
For grade?
Yeah, it looks like.
I think grade is using small int. That's
I click? Oh, I clicked it wrong place. Okay, small integer, yes. It is request ID is big integer, so it's wrong one. So it is small integer. So this is right. So it is right. Questions? Okay. Now we're about to finish. We have 5 minutes till the end. Just play with it, see what it's doing.
So is the request pet table just mapping the request and the pet together?
Okay, let's open request. This one?
Yeah.
Okay. It is artificial table that is required each time when we have many-to-many mapping. We cannot implement it otherwise. Otherwise, it will be broken database.
Okay, so for every...
It doesn't have any specific meaning. It is just formal requirement. We cannot make it a many-to-many mapping without additional artificial table. And this is it. And this is additional artificial table must have at least ID of on one side and ID on the opposite side. In addition, it may have extra data. In this case, it's not. In some cases, it may have extra data. Let's think related to relationship. It could be some property of relationship. Yeah, I cannot imagine the property in this particular example, but some relationship do have properties on its own. Oh, okay. Let's go back to example in our mind without opening code. Example for another many-to-many relationship between users and roles. Right? We know that users can have roles, and roles may have multiple users associated with that, right? So it's many-to-many. We can add property like, for example, date and time, or when user was assigned a given role. It's not a property of a user, it's not a property of a role, it's a property of the association, right? When user was given this role, right? So in this case, it will be additional field in this many-to-many mapping table. Okay, when this role was assigned to given user. So technically, it could have the additional fields.
So it would look like role, user ID, and then when it was assigned, or how it would.
Yeah, so it will be ID of a user, ID of a role, and date time when it was given to user. Yeah. So it's not a property of a role, not property of a user, but it's kind of property of association, right? Association between them. All right, questions? No? So let's relax and